Hey guys, welcome back from spring break. We're going to start out with 12.2 part 1 surface area of prisms. You're going to see surface area abbreviated to SA a lot, so just know what that means. You're going to need your notes, so get your notebook out. We're going to write some definitions and get that 12.2 practice sheet because we're going to be working along with that. Just a quick reminder, you can pause and fast forward this video as much as you'd like. I'm going to go through each example and it might take a little while, but if you get it, feel free to fast forward. Alright, so the first definition we're going to write down is a prism. It's a solid object with two identical ends and flat sides. So for example, a prism will look like this. I know a lot of you have drawn these before, like a cube, okay? That's a prism. So see how I have two squares, one is behind the other, and then if I connect them, it makes like a 3D object, right? Like a long rectangular, that's called a prism, okay? And there could be other types of prisms. There can be triangular prisms. I'm not very good at drawing those, but it is what it is. There's pentagonal prisms. I'm not even going to attempt to draw those. Lots of prisms. It's like taking one shape and kind of stretching it out longer, and I'll show you a video of what that looks like. Actually, I'll show you a video right now. So we're coming back from the video. There's a couple names. The lateral faces are the faces that are not the bases. So in the ones I drew here, these rectangular, like the rectangles that are on each side that we kind of stretched out, those are the bases. That's the identical end faces. And all these other sides, so this side right here, this bottom right here, it's kind of hard now that I'm scribbling all over it, but every other side is called the lateral face. So in the triangular prism, those triangles are the bases, and remember the bases are identical. They're right opposite each other and they make an identical shape, okay? Those are the bases. And these other sides all around, those are called the lateral faces. All right, so a couple other vocab words to know. So lateral faces, this arrow is pointing to all of these sides here, this side, this side, this side, okay? And the altitude is from the middle of one of the bases down to the other. That's how high, you might also see me say height, and I'm going to use the capital H. That's the height of the base. Now, if I had turned this prism on its side, this is still called the height. I'm going to try to draw it for you here. So like for example here, this right here, from the middle of this base to this base right here, that's still the height. I know it's not going up and down. The height is really the distance between the bases. So if you need to write that down, that's a great idea. And again, we're going to use capital H. The lateral edges, we're not going to talk too much about those today, but the lateral edges are the edges that connect the two bases here. They are also the same length as the altitude. Okay, this is called a pentagonal prism. We name the prisms based on the shape of their bases. So because the bases are pentagons, that means we're going to call it a pentagonal prism. So let's do a little practice here. So this first shape, the shape of the base, this prism, the shape of the base, because these are the two identical that are across from each other, those are triangles. So this is a triangular prism. Okay, I want you to pause real quick and try to fill in the rest of these. Let's call this 1, 2, and 3. What is the name of number 1? What is the name of number 2? And what is the name of number 3? Remember, you're looking at the bases. So go ahead and answer that. And these are your answers. Rectangular prism, hexagonal prism, because this is a hexagon here, and triangular prism, because these are triangles. Now remember, the bases might not always be on top and bottom. They might be side to side. It's whatever shapes are identical and right across from each other. It's kind of like the shape that you took and stretched out to the other side. Okay, so it's like I took this pentagon and stretched it out to make a prism. Okay, now this rectangular prism, one quick thing to note, I could have chosen that front face as my base, okay, because it has a matching one on the other side. I could have also chosen the top and the bottom as my bases, because those are also matching and opposite. And I could have chosen this and this as my bases, because those are matching and opposite. Rectangular prisms are the only prisms where there could be multiple bases, okay? The rest of them, triangular, hexagonal, pentagonal, anything, those all do not have multiple pairs of bases. Rectangular prisms are the only ones that do. So we're going to put in a couple more definitions. Write this down. Pause, please. Lateral area is the sum of all the lateral faces, not the bases, okay? The total area is taking that lateral area and adding the area of both the bases. This is often called the LA and TA. LA means lateral area and TA means total area. All right, so looking at this first example that's on your practice sheet, it says draw out the pieces and find the LA lateral area and TA total area. I'm going to show you a video of someone who's actually taking apart each piece and finding the total area first. So I'm going to pause and show you that video real quick.
How could you find the surface area of this triangular prism? Again, it's all about looking at it in terms of the different faces. So it's got two rectangular faces there and there. It's got two identical triangular faces there and there. And then it's got another rectangular face at the bottom. Okay, so let's take the triangle first of all. Two triangles, remember, and they have a height of 10 centimeters and a base of 9. We've got these two rectangles that have a base of 11 and a length of 12. I'm using the words height, base, length, width interchangeably because essentially, as long as I know which dimension I'm talking about, I can see clearly which ones I need to multiply. Then there's another rectangle here. This has a length of 11 and a width of 12. And then we can start to find out the area of all of these. So triangles, to find the area of a triangle, you need to multiply the vertical height by the base and then divide by 2. So 10 times 9 is 90, divided by 2, 45 square centimeters. So this one's also 45. This here has an area of 99 square centimeters. This one's 132, and so is this one. Okay, adding these two together, 453 square centimeters. That's the total surface area of that triangular prism.
Okay, so now that you've seen how he was able to find it, I'm going to show you another way by drawing out a net, okay? And this is a net right here. And let me show you, I'm going to pause again, I'm going to show you another video of someone else who can kind of show you how a net falls apart. What's happening is the triangular prism is falling flat so that we can draw it. So I'm going to pause right here and show you that video.
Now let's try to draw the net of a triangular prism. Let's take its duplicate and dissect it. There are many ways in which we can open it up along its edges. We can start off by opening the rectangular face on the right. Then we can open up the rectangular face on its left. Then drop the two triangles to get this. This is the net of a triangular prism. And the top view will look like this. The yellow and the red rectangular faces are the faces to the right and the left of the prism. The black one is at the bottom. The green and the blue ones are the identical parallel faces in the front and the back.
All right, so now that you've seen how I drew the net, I'll show you it's a little bit easier now to find each area separately. Okay, so I draw the net, and over here, so for example, this orange square, I was able to take these measurements from the orange square at 12 and 11 and get 132. Just like how the guy in the video did at first. And I was able to find the area of the triangle using those measurements. I was able to find the area. Now these triangles are the same. Remember, bases are identical. I was able to find the area of that green square that's on the bottom. I was able to find the area of the pink square on the top or on the right there. So the lateral area is the area of these rectangles here, the lateral faces, the faces that are not the bases. So the lateral area I found was 132 plus 99 plus 132. Okay, that's my lateral area. Now, my total area is when I take that lateral area and I add both of the bases. Okay, so I'm adding 2 times 45 and I'm getting 453. So that's the same answer that the other guy in the video got. I'm just showing you how to draw it 2D here. Two things that we need to add. There's formulas here for lateral area because we don't have to draw it out every single time. That's the long way, okay? There's an easier formula, okay? And the easier formula is take the perimeter of the base and multiply it by the height. Because now remember, we are taking the base and we're stacking it. So what we're doing is taking that perimeter, we're stacking it up by the height. And when I say height, I'm using capital H. I'm talking about the height of the prism, right? The distance between the bases. And this is the formula for the lateral area, just those lateral faces. So if you need to write those descriptions in, not a bad idea. The total area is, again, just the lateral area plus both the bases. All right, so let's get started on some example problems. Number 1, it says find the lateral and surface area of each prism. All right, let's do it. The reason these questions here are on the side is to make it a little bit easier for us. The shape of the base. So which shapes are matching and across from each other? It's kind of like those shapes got stretched out. It's these triangles here. Those shapes are facing each other and they match. So those are our bases. So the shape of the base is a triangle. All right, the perimeter of the base. So the perimeter of this base is, I actually just drew it a little bit bigger so we could see. 3, 4, oh, I know what this is. 5, 3, 4, 5 triangle. So the perimeter is 3 plus 4 plus 5, so 12 meters, okay? The height of the prism, now remember the height is that distance between the bases. That's 10. Okay, so it needs us to find the area of the base. Okay, so I'm going to use big B, okay, big B for area of the base. So the area of the base is a triangle. So we have to remember what our area for a triangle formula is, and it is 1/2 base times height. So our base here is 4, and our height here is 3. So that gives me an area of the base, big B is 6. All right, so now this is where it comes in, lateral area and total area. Remember, my lateral area formula is perimeter of the base times the height, which is why they asked us in the beginning for the perimeter of the base and the height. So my lateral area is perimeter of the base, 12 times the height of the whole prism, capital H, 10. So 12 times 10 is 120. Then the total area, remember that formula is the lateral area plus 2 of the bases. So lateral area is 120, my bases are each 6. So 120 plus 2 times 6 is 132, and I gotta put units. This is area, so it's meters squared. All right, pause and try number 2. What is the shape of the base? Now remember, for a rectangular prism, you can have multiple bases. You could either choose the sides here, you could either choose the back and the front, you could choose the top and the bottom, okay? So just for consistency's sake, let's all pick the front and back. All right, so the perimeter of the base, well, I'm going to draw it big down here again. 10 and 15, meaning that this is also 15 and 10 right across, so the perimeter is adding all those up. So we get 50. So the height is the distance between those bases. So this right here is our height. So that's 8. The area of the base, we're going to use big B for area of the base. Well, this base is a rectangle, and the formula for area of a rectangle is base times height. Do you see why I used big B and little b? Because little b is usually what we do when we are talking about base, aka base of just like a rectangle, okay? So the base of our rectangle is 15, and the height of a rectangle is 10. All right, so we have 150. So now we're ready to find our lateral area and our total area. We have everything that we need. All right, so our lateral area, again, is perimeter of the base times the height. So the perimeter of the base we found was 50. When I'm talking about height, I'm talking about capital H, the height of the prism, aka the distance between the bases. So that's 8. So that means my lateral area is 400. So we're going to go ahead and try to find the total area. Total area formula is the lateral area plus 2 of the bases, and I get 700 for that one. All right, let's go to number 3. Again, if you can do this on your own, please go ahead and fast forward. But otherwise, we're going to go through it together. So number 3, shape of the base. What is that? It's a pentagon. In fact, it's a regular pentagon, which is going to really help us out. So the perimeter of the base, well, if one of the sides is 6 and there's 5 of them, that means it's 30. The height of the prism means the distance between the bases, so that's 18. All right, now for the area of the base, I'm going to try to draw it separately so we can figure this out. And there's my fabulous pentagon. Okay, we have to remember how to find the area of a regular polygon, because the big B area of the base is going to be the area of the pentagon. And I remember what it is. 1/2 times the apothem times the perimeter. Okay, well, we have the perimeter is 30. We just need to find the apothem, which is everyone's favorite part. That's my apothem right there. If this is 6, that means this is 3 and 3. And I'm going to make a little right triangle here. This is a little review from last unit. So each of the angles in a pentagon is 108. Use that angle formula. So that means when I divide it in half, I get 54 and 54. So this triangle right here is a right triangle, and I can use tangent to find the apothem. The tangent of 54 is the apothem over 3, so A over 3. And when I solve for A, we'll call that 4.13. So I'm going to put that in for the apothem. So when I go to finish solving for the base, I'm going to multiply all that, and rounding I get 61.94. Okay, so now we have enough information to find the lateral area and total area. So the lateral area formula, perimeter of the base times the height. Height is big H, so height of the prism, which is 18, so 30 times 18, and my calculator is 540. And this one took up a little room, so the total area is the lateral area plus the 2 bases. 540 plus 2 times 61.94. 663.88, and my units are inches squared. All right, moving on to number 4. What is the shape of this base? If you said trapezoid, you were right. Okay, so the perimeter, I drew it bigger. The perimeter is 49. The height of the prism. Now, key thing. The height of the prism is not 8. Okay, not 8. We're not talking about the height of the base. We're not talking about the height of the trapezoid. We're talking about the height of the prism. Height of the prism is the distance between the bases here. It's 12. All right, area of the base. We use big B for area of the base. And in this case, the base is a trapezoid, so we're finding the area of a trapezoid. So 1/2 times the height, B1 plus B2. Let's do it. Height is 8. 10 plus 20 for the bases. 120 for the area of the base. All right, so now we have enough information for the lateral area and the total area. Lateral area is the perimeter of the base, which we have 49, times the height, big H. We're talking about the height of the prism, not the height of the trapezoid, not the height of the base. The height of the prism, meaning the distance between the bases. That's 12. 588 for our lateral area, and so then we can use that to find our total area. Lateral area plus the two bases. 588 plus 2 times 120. Our total area is 828 units centimeters squared. All right, number 5, shape of the base. What is the shape of the base? It's a square. Notice how this is 4 and this is 4. Right? These are the same, must be the same length. So that means that this is a square, 4 and 4. So the perimeter of the base is 16, right? Add up all those sides, 16. The height of the prism, not the height of the square, but the height of the prism is 12. The area of the base times height is 16, right? Big B is 16. All right, our lateral area. Perimeter of the base times the height. Height of the prism. I got 192, which is going to help me find the total area because it's the lateral area plus 2 with bases. So I got 224 inches squared. All right, last problem. Number 6 says find the lateral area and total area of an equilateral triangular prism. Okay, big hint. What's the shape of the base here? It is an equilateral triangle. Nice. Okay, so the perimeter of the base. Well, it tells us the perimeter is 12 inches. Let's fill that in. Then it asks for the height of the prism. What do you know? It tells us that too. So we have most of our things filled in here. Now the next thing we need is the area of the base. Well, the base is an equilateral triangle because it tells us that's what it is. And if it has a perimeter of 12, that means each side, because it's equilateral, must be 4. And then we know how to find the area of that. We draw in an altitude and solve. So I did the Pythagorean theorem, and I got x is root 12, but I should simplify it to 2 root 3. So the area of the base is the area of the triangle, which is 1/2 base times height. So 1/2 times 4 times 2 root 3. I have the area of the base is 4 root 3. All right, so that's going to give us enough information to find the lateral area. The formula is perimeter of the base times the height of the prism, which is 10. So 12 times 10 is 120, and the total area. Sorry, I'm running out of room here. So lateral area plus 2 bases. So we got 120 plus 2 times 4 root 3 is 120 plus 8 root 3. Remember, we cannot add those. It is not 128. It is 120 plus 8 root 3. And my units are inches squared. All right, that's it. I know this is a really long video, and I am sorry, but there's no Zoom, so hopefully you use your time wisely. And there is a homework assignment, and you're going to turn it into Shobi. See you next class.